Yeah. And then, what's the next step? Of course, that red dot is because it's already there. Okay. But what I give you is without the red dot. And next step, R over D is 0.1. There. And then use your eagle eye. It is. What would you say it is? Hmm? You know, this is 1.8, this is 1.4, so this is 1.6. I say 1.42. Okay. Now, one more variable to remember. This is KTS. This was KT. This is KTS, and the S signifies shear. Okay, because torsion creates shear, bending creates normal. So KTS. One more chart. All right. QS. This again is a not sensitivity, but it's for torsion. The way you notice this chart will be Q shear. If you see shear, that's torsion. Okay. What's the first step? To look up this chart? Not the OD this time. The radius. What's our radius? 2.8. So this is R equals 2.8. Next. What's the next variable? SUT. What's our SUT? 0.7. Okay. This is PSI, by the way. This is GPA, so gigapascal. That's our line. Yeah. Okay. Give me your 0.905. Zero point 92. Okay, so again, this is shear. Okay, I'll say KTS and QS. So those are my stress concentration lookup. This is based on figures. Okay? Final step. Well, not final, but we calculate KF, and this is a combination of KT. Sorry. The formula is 1 plus Q times KT minus 1. So it's 1 plus 0.85, 1.68 minus 1, and 1.58. So this is the stress concentration, the fatigue stress concentration factor for bending. For this one, it's the same formula. KFS is 1 plus QS, KTS minus 1. So it's 1 plus 0.92 times 1.42 minus 1, 1.39. Any questions? So these are the two variables you look up from the figures, and then you combine them this way. And we're only halfway into the problem. Okay, I have an urgent meeting I have to attend to, maybe 10 to 15 minutes, I'm sorry. So let's take a break. 10 to 15 minutes, we'll resume this problem?
So can I look at the one for the game teaser, the graph maybe?
Okay. You can, the slide is on Google Classroom. Yeah, you can, it's probably best if you zoom in there.
Yeah, I think it's here, take a picture.
Okay. All right. Go ahead and take a break. 10 to 15. I'll say 15. Huh?
Very straightforward.
Yeah, it's pretty straightforward. Just picking up charts.
During the quiz, the charts will be there at some point. Yeah, of course, we're not.
Zero point.
Yeah, 4 charts. You make it. No, it's from the picture. It's from the question. See? 1.42. That's the time. That's the timer. Yeah, this one is the thing. 1.42. Yeah, that's find the moment and the Overwatch itu Steam sama Battle.net itu bisa gabung. Udah, terlihat kan? Gue belajar dulu. Alumni CS Palu. Iya. Tapi itu kenapa rame lagi sih? Gimana ceritanya? Enggak rame lagi. Overwatch 2 kan jelek. Iya. Dia season 1 kan? Overwatch jelek tuh. Fiji banget. Boost. Fiji banget. Kemarin Overwatch lagi ya. Habis lagi gue habis.
Kita mau itu lama-lama di band Overwatch wifi-nya itu nggak bisa fail aja. VPN Overwatch jadi gue nggak pernah main.
Fail di sini.
Sekarang udah nggak bisa login.
Dulunya di Steam juga di Battle.net cocok emang. Gue semenjak Steam ini tempat terus butuh VPN.
Dulu di Battle.net crash terus itu login itu gara-gara
gitu lo lagi mancing banget.
Jadi lu sebenarnya soalnya sudah pengen banget mancing yang depan channel.
Iya, boleh tuh nggak dapat selalu
Ada ikan apa di sana?
kalau di tempat gue ya, kalau rak itu 47 sama ikannya, gue suka mancing. Banjir. Oh no.
Lu masih main Valor?
Baru dan baru gua uninstall. Soalnya udah seru. Mana?
Bosan ya?
Kalau main kayak gitu minimal bertiga seru. Kan kalau berlima dua nggak jelas ya, kayak bertiga deh gitu kan. Kalau lu sendirian terus empatnya nggak jelas kan.
Emang juga gitu kan? Enak itu ya minimal 3, 4, 2.
Iya. Tapi kan harusnya main CSGO di server Eropa sih banyak Rusia. Kau lihat pasti. Kau lihat terus. Seru banget.
Michael Jordan.
Iya, gimana?
Ada game seru ya. Main CS cuma buat notification doang.
Dulu seneng banget dulu sama masih ada musik.
Sekarang mati lagi.
Apa namanya X-Dota gue suka masih X-nya. Biasanya kalau X baru keluar kan sama tuh. Nanti gue main sendirian tuh. Nanti gue udah drop jualin. Kalau gue jualin lu enggak.
Waktu itu harganya musiknya 300.000. Ya, itu 2,3. Terus gue jual gue cash. Cuma gara-gara main game doang.
Gue dulu judi sih. Seriusan, di CS2 launch.
Oh, tahu kan?
Zaman dulu banget, sekarang udah tutup kan?
Iya.
Gue sudah satu saat Asimov, dulu apa-apa. Hilang semua gitu. Gila gitu.
Fokus.
Harta gue yang set up tuh warna hijau. Kayak emerald tuh warnanya.
Halo?
Iya. Ompaknya jadi seru gitu.
Kalau gue jadinya Grotopi.
Sekarang apa tuh itu?
Lu pernah lihat cuma nggak pernah.
Grotopi ya. Judi apa sih? Ini.
Itu ada lagi zaman populer.
Lu ngecek udah kan tahu judi nggak?
Judi jadi dulu ya grinding terus punya kayak budaya lu sih lah.
Mana judi kan?
Ada kasino dulu dulu.
Oh,
Grotopinya scamming orang.
Itu aja prank. Judi bro gitu.
Siapa yang baru di Grotopi? Lu?
Ya ini sepupunya. Judi
zaman SMA gue mah
siapa berapa juta?
Sehari bisa 5
Jadi dari judi itu.
orang ya?
Enggak,
Jadi
kasino.
Terus gimana bisa profit terus?
Blackjack menang terus.
Main blackjack, ada banyak gamenya. Gue udah cobain semua. Terus dulu gue pernah jadi bandar juga. Gue punya usaha kan.
Hebat jadi. Gue Ricky udah mati.
Iya, jadi
Lu nggak main ML mas?
Enggak ya.
Gue ajakin nggak mau.
Tahu foto.
Gue juga
Itu
dulu.
kan game-game dulu waktu Dota down atau apa
Iya,
namanya
iya.
itu orang kesana semua kan free kan.
Terus itu juga ada judi lagi, kayak CS gitu online.
Oh dia buat dia kayak jualan banyak perintilan murah-murah gitu deh.
Iya,
kan.
benar.
Iya kan. Pasti kita apa ya?
Biasanya kosmetik aja
Oh,
sih.
betul.
Nah itu keysnya,
Itu kalau jual di sini itu terlalu gede itu potongan sebenarnya.
teks. Jadi sama nggak sih teksnya sama?
Lu nggak tahu kalau dalam euro itu gede banget.
Oh.
Jadi aku tahu tiga tanggalan menurut saya sudah semua
Gue mirip
storage,
mirip jika nodas juga.
sisanya udah frame semuanya udah.
VPN ada kayak apa film-film Amerika.
Ya bisa nembak cuma
Ya, jadi rank gue itu rank tinggi ya, rank 3 itu aja, sisanya semua juga.
Lo hari apa sih?
Karena suara.
Gue zamannya itu kayak 3 DMG di sebelah
Oh.
tapi teman-teman gue itu pada diskusin main sama global itu gue males. Soalnya terlalu gampang. Suka nggak kalau miskin aja. Di Jerman itu
diomelin ya?
ngobrol. Jadi gue sama pasukan kecil belajar semua kan gue bikin lainnya kalau gue sempat main di TikTok juga yang tiket tinggi.
Oh tiket tinggi.
Apa sih namanya?
Ambil diri itu. Tiket itu.
Ya kan jadi kan
Visit.
ya visit.
Ya gue juga pernah visit. Gue visit 8 ya?
Kalau di visit udah nggak terlihat.
Ya gue level 8 aja udah kayak helm gitu anjing.
Kalau apa? Refresh dari monitor kuring
Dulu tuh kan gue udah gak bisa apa-apa.
bukan
Belum lihat orangnya udah mati. Tapi gue waktu itu main Valor kan Valor 2020.
iya gue ingat tuh pas di Twitch gue nonton dan dapat drop
Iya bisa download. Nah itu gue waktu itu gue masih 60. Jadi kan gue max 100 doang. Tapi gue bisa imut.
oh iya
Terus
gue plat dulu sih kalau tapi dulu early itu nggak terlalu susah sekarang sih sekarang susah banget ya tergantung partian sama siapa sendiri
gue tadi nanya dulu Radiant gue tinggal sejam turun lagi tuh gimana lagi kan sore sejam kan bisa bukan poin lagi
ayam kita ya beli kan jadi kalau di kan
gue punya skin ini
bukan kalau sih gue ada tiga negara
Iya,
makanya
makanya.
yang itu yang Valorant
oh ya
kan jauh lebih murah juga
oh gitu sama lain juga berarti
gitu. Jadi beli batu jauh lebih murah. Kalau dulu pasal
Iya.
Iya.
kayak skin kan gue kira
Iya.
murah banget
Iya, Google
bisa gamenya
Ada gue temen lagi.
murah juga ya
Masa sih nggak ada makan?
dulu Oni apa skin Oni itu udah wah banyak sekarang banyak banget.
itu udah keren banget lu kayak gitu udah price banget aja
Iya, mana sih ya?
Battle Pass juga gue gak pernah miskulah gitu.
udah pasti ya
Gue yang beli.
Head lamanya sih harusnya ada grupnya.
Tapi gue dapet info dari Marco aja. Dari siapa?
Iya, karena head lama ada
Dulu
grupnya.
Iya.
sempat
Oh itu lebih sering banget.
Kan kalau mobil masih
Enggak salah.
Head baru udah ingat yang mau di
ya gue enggak bro mobil lah
tahun lalu
Head tadi.
gue sempat di PT gitu pas gitu.
Iya antara angkatan kita sampai
Mobile ngecit.
nyicip
Jadi kayak di HP-nya tuh kayak udah garis-garis
ya ampun
protek atau apa.
buang
Medikus si, aduh gue lupa namanya.
Gua
Anak MIT. Anak MIT.
hampir nyoba cuma udah masuk TV karena itu ramen
Halo.
nggak works lah.
Education.
Gue nggak tahu
Ada sih.
gue dulu waktu di kantor kemarin gue sama
Gue
udah pakai tas bogi gue udah semua
Medikus kelowisakan.
jadi lo pakai PB gue masih
Seperti yang tidak kaget kepala si JCC.
pokoknya dulu tuh namanya masih di mana Pak
gue di Taman Anggrek.
gue pegang P90 gue pegang
Wah, mati Chris.
itu apa
Gampang banget cepat itu senjata. 5 kali
semua dulu ngecit sempat ngecit juga waktu udah mau pensiun ya banyak video lengkap kan gue ngecit
banyak fitur sama males.
dulu pensiun nggak bisa jadi gue kayak pura-pura sampai lagi gini
Lagi ya begitu.
dupe
Apa tahu? Apa nanya doang?
gue nggak terlalu
Parah. Gue cuma nanya.
gampang gue pas lihat tuh
Ya.
Jadi
happy spot.
Ya itu turnamen sekali itu udah
lu di warnet nggak sebenarnya
Tahun lalu
di mobile juga udah pernah.
Tahun lalu Febrian doang.
Mana ya? Gue males
Pupuk.
kayak ranking
iya iya
sama sekali gue sampai kayak trip sampai banget rada mager ya.
Kok harganya semua?
Ya bukan main gitu jadi kayak sudah tapi dulu
Waduh.
gue inget di SMP tuh pas SMP gue udah bikin baju itu kalau abang-abang
Ardi.
gue tuh udah main orang di step semua gitu kalau kita main publik kan kita main lari ini udah dapat itu headshot tadi gitu
Buset, iya waktu di mall waktu itu Taman Anggrek sama di Pondok Indah tuh gue waktu itu main itu ini
Jadi ini share-list itu dia
gue beli game ya
setup konselor sama konselor juga.
tapi gue main komunitas itu
punya apa punya apa
punya jadi gue mainnya track dulu
Jadi konselor cuma 2 orang.
itu anjing
Dixon juga.
kenal get right
Kayak ada dulu
ya
itu mainnya kalau gue mainnya dari atas
oh
jago banget dulu banyok nggak jelas
Apa dia nggak ngisi ini kali ya? Nggak ngisi form.
lu main MMO kecil
ini wow
oh
memo
ada Frozen Throne
ya bukan Dragon satu kan
oh Dragon Age
udah itu doang terus paling baru yang Star Wars Republic terus Albion
itu susah tuh tukar nyawa tuh main kayak gitu tukar nyawa aja
berapa jam tadi itu gue kan bisa main MMO itu sama teman
iya jadi gua
rate gitu
ada warnet juga terus gua main di rumah juga ada Speedy dulu kan dan gua internetnya
oh namanya
itu
Speedy
pasti juga
terus
Wah itu, apalagi kan ada 3 kali watt kuat panas yang malam. Gue bangun pagi, dari SD itu ngumpul mau apa aja.
Download it and watch it. Smile one.
You have this like smile.
All right. Okay. I need to continue. So we gathered all that. The next step is to actually calculate the stresses. Remember, we are doing stress analysis, right? So ultimately, we need to do this. Going to the stresses, because these are just the multiplication factor, right? But what is the actual stresses? So these are the two formulas that are given. It's called von Mises stress. Okay? The symbol is sigma with a prime. There are two kinds of von Mises stress here. Just like these are alternating and mean. Mean means average, right? Mean means average. So this is alternating. This is mean. This is alternating. This is mean. Mean means the static. Okay? Average, static, steady. Alternating, fluctuating. So von Mises also has the alternating and the mean. Okay? This is a bit small. So this is the formula for mean. This is the formula for alternating. And you can download the slide if you want. Okay? Now, this is the formula. Again, I will not go through the derivation. But I want you to notice two elements in this formula. Let me show you the big one. Sorry. I have a bigger version. Okay. Here. There. Okay. So here's the alternating. This is the mean. The alternating von Mises stress is affected by two big terms here. And this is MA. And I'll just highlight it. This is MA. This is TA. Von Mises mean is affected by MM and TM. So I would like to highlight those. These are KF and these, other variables. Now, in most cases, if not all, a shaft under radial loads, and do you remember radial? If this is a shaft, which way is the radial load? It's vertical, right? These are the bearing supports. These are the radial loads, right? Radial. Axial is this way. Not too many axial loads in shaft. Okay, and then there is torsion. In most cases, because of this radial load, they create bending moments, and the bending moments is the fluctuating one. So, in most cases, you will see this. 0 and 0. And this is usually described in the problem, and I will describe it in the problem, right? A fluctuating moment means no average moment, and a steady torsion, no alternating torsion. And so the beauty of that is that this formula simplifies to that. Because the TA is 0, so that terms goes out. MM is 0, that terms goes out. Okay? Pretty clear? So Now let's do this formula then. Sigma A prime then is 32 times 1.58 and this is the small d, and I'm doing this all in meters. Okay, this is zeros. I got the Kf from here. Okay, this is Kf 142 and 5d, small d, in meters. So that's the fluctuating or alternating von Mises stress. The mean von Mises stress, and I'm taking this is a power to the half, okay? This entire thing is, sorry, then this is, no, because it's square, sorry. So the formula, this is square, this is half. So the power of half means square root. So that cancels out. Here, this entire quantity is power to the half, which means this is a big square root. But you have the constant 3, and that's why it comes out like this. Any questions on using the formula? So, that's 0. Because of the square root, then it's square root of 3. And this quantity is square root, so cancels it. Now, what does this mean? This means that if I draw the graph of stress versus time, there is a mean component to this, which is 69.4, and plus and minus, that's not symmetrical. So think about it this way. So at the peak, this is plus 104 minus 104. Okay? So this is the mean. This is the alternating. So my shaft at the maximum point stress concentration factor here, right here, what am I seeing? I'm seeing 69.4 plus minus 104. So it's a combination. There is a static quantity, which is 69 plus minus 104. And that happens for a long time, right? How do we combine these into the safety factor? Now, how many of you understand safety factor or factor of safety? If I say the stable capacity is 100 kilograms in the brochure, but in reality, it can sustain 200. So what is the factor of safety? 2, right? Because the real capacity is 2 times what I advertise it to be, or what I claim it to be, the official. So if we have a loading, say, I loaded 100 kilograms, but the reality, this table is designed, and this is only the engineers know it, right? Not the customer. but the reality is 300, then it's 3 times. A typical factor of safety for elevator is like 12 times. So even though the elevator says what is it? Our elevator here? 1,000. Okay. How do you memorize that? Okay. So 1,000 kilograms. Then in reality, it can actually sustain 12,000 because it has to be very safe, right? So that's the concept of factor of safety. Every engineer always designs something with a margin of safety, right? And it's a factor of safety here. So in the case of single load, it's easy. You just divide, right? Factor of safety, and you just divide the failure load divided by the design load, or actual load, sorry. So the real failure versus the actual. And when I say design, meaning like, in a design problem. So think about it this way. But in order to do the n on this one, the formula is a little bit complicated. So 1 over n is sigma a prime divided by SE plus mean divided by SUT. So 1 over n is 104, 205, so n is equal to 1.65. This is the fatigue factor of safety, not the static one. This is the fatigue one because we incorporate the alternating one.
That one's the static one. More different one.
This is just a general definition of factor of safety. Okay. So you see in this formula, the comparison is a combination of alternating and mean. The alternating component is compared with SE. Remember what SE was? Endurance limit, which is kind of the infinite life threshold. Which kind of makes sense because this SN chart, the lifetime chart, is talking about alternating stresses. But the mean component is actually compared to the static ultimate strength. SE is, think about it like the fatigue strength. This is the static strength. But we also, this is called the Goodman failure criteria. Somebody is smart enough to come up with it, obviously. Okay? This formula is called the Goodman failure criteria. Finally, we also want to check for yield, for static yielding. Because who knows that the mean is dominant enough that it actually failed in the first cycle, right? We are safe for infinite cycle. We are safe by a margin of 1.65 times. But what if it yield? And the way you check this, it's basically even simpler because the maximum point here can be approximated by summing them. And so 69.4 plus 104, that's 173.8. And so our static factor of safety is the yield stress. Sorry, I forgot to put the yield stress. Yield stress, which makes sense, is lower, right? You yield first and then you snap. Yield stress divided by the max. Von Mises. So we have 574 divided by 173.8, 3.3. So my static factor of safety, think about it that way, is 3.3 times, which is good. Like, I'm even safer statically, but naturally speaking, fatigue is more dangerous or risky.
Sir, is the yield strength like written in the question?
Yeah, this is a material property. It's not written. I'm sorry, I forgot to write it down. Okay. This is given. Usually SE is not given. But again, because I skipped a chapter on fatigue failure, spare you guys from theory. So that's this problem, right? If we go back to the original problem statement, right? Determine the fatigue factor of safety of the design. That's the answer. Determine the yielding factor of safety. Static yielding is compared to the S1. Okay, questions? Yeah, this is kind of my, I don't know, I like to think about it this way, right? Strength divided by the actual stress. It's like also your strength of surviving SGU lessons divided by the stress of the actual classes. Or capacity compared to demand. Okay. But because we have two components here and two comparisons, we have to do a reciprocal formula. And the static yielding in shaft, you can estimate it to sum it up. Okay? I think we have time for I'll skip this. Okay. Let me give you an exercise. Let's exercise here. This is a very similar setup. I just want you to exercise doing this. Okay. I think I'll copy paste it to the slides so it's clear. Okay, take out a piece of paper. You'll actually submit this. Oh, come on. Nobody use paper anymore. Okay, is that big enough? I guess you can do it in tablet.
I guess you can do it on tablet.
So I just changed the numbers basically. Go through the same procedure. Use the charts that are on the slides.
Also, charts are on the slides.
Yeah. I guess if you have a tablet, feel free to write on the tablet. It's fine. And then submit it as Google Docs. Yeah, I send. Is this week 2 or week 3?
Freezer.
Just go through the slide. PowerPoint slide of the lecture.
Is it the same one as before?
Same.
The same one. Oh.
It would be a good idea.
Yang bawa chef design. Makanya aku dulu kira-kira.
So do you approximate the KT, the K and the Q, sir?
What's that?
Do you like approximate the K and the Q?
Yes, using the chart.
Because before the DOT is 1.5, so this means there's like
Oh yes. You have to eyeball it.
I wanted this.
Tolerance eyeball.
Sir, is it a must to draw a diagram?
Which diagram?
Out of the four.
Visualization.
No need that, sir.
Oh,
The shaft.
this diagram?
Yeah.
I think it's helpful. You don't have to.
You don't have to, okay.
What you're afraid of drawing? I'm not grading on the drawing, I guess. That's the question. I won't evaluate you for your artistic drawing.
Iya. Dari yang satunya dua
So this is going to be typical of the calculation quiz for the course, right? Just one problem like this on paper. Yeah, I'm a bit old school on that.
Iya,